A domain and range of functions. Well, as I noted earlier, domain means it's collection of all possible inputs, and range would be all possible outputs. So let me start with an example here. Suppose you have f of x equal to 1 over x. Now, are you allowed to plug in 1 into this function? Yes. Okay. Can you plug in 2?
Yeah.
No problem, 1 over 2. Can you plug in negatives? Negative 1, for example.
Yes.
Yeah. What's not allowed to be plugged in? 0 would be a problematic number because you cannot divide by 0. So you can't have 0 in there. So if you represent the domain on the number line, here's 0, 1, negative 1, and so on and so on. That's the number line. And everything except 0 is the domain. Now let's try to write this as an interval notation. How many intervals do you see? See, 0 is not allowed, so the moment you delete the 0, how many pieces do you see? 2 pieces. One here, another one here. How would you represent this side? Where does this one start from? Negative infinity. Where does it end?
Positive.
No, it can be it can get as close as possible to 0, right? It's not negative 1. It could be negative 0.5, negative 0.2, negative 0.1, and so on and so on, right? So it's all the numbers right before 0. And how do you write that? You write 0, but not included in 0. So this parenthesis means that it doesn't include 0. Okay? So you start from negative infinity, and for infinity or negative infinity, you always use the parenthesis, not the square bracket. Square bracket would mean including, and negative infinity or infinity, these are not considered as real numbers, so you always have to do this. And then there's another piece which starts from 0, again not including 0, and goes up till infinity. And if you have more than one piece, you put union between them, and that's your domain. Okay, now usually finding the range is a hard question. You need to know the graph in order to find the range of a function. But here, you can kind of make a guess. Like, can you make this function produce a very big number, say 100? What should you plug in to get a 100 out of this function? One divided by what is 100? 0.01. If you divide by 0.01 is 100, right? And you can see that you can put other numbers, 0.001, 0001, and so on and so on. Those can be plugged in, and that way you can get any number that you want that's positive, right? Now let's think about a negative number. Can you plug in some value in here to get a negative 100? Can you get that? Huh?
Negative 0.01?
Yeah, negative 0.11. So if you plug in negative 0.01, you're going to get negative 100, right? So now you see that you can plug in pretty much, you can kind of figure this out to generate any positive number or any negative number. Now, is there anything that this function cannot produce? Is there any number that this function cannot produce? Zero. So think about this. Can some input make this equal to 0? That's the question.
No.
For some x, that's the question, and you immediately see that this is impossible. If you multiply by x both sides, then XX cancels and you get 1. 0 times anything is 0, so you end up with 1 equal to 0, which is impossible. Right? So after some consideration, you can conclude that the range is also all real values except 0. It's exactly the same as this. So you have negative infinity up till 0, union 0 up till infinity. Okay. Now, what's the proper way to figure out the domain and range should be if you know the graph. Okay, so let me give you the graph of y equals to 1 over x. If you plug in 1 into x, you get y as 1, so you know that the point 1, 1 should be in the graph. Same thing for negative 1. If you plug in negative 1, you get the y value as negative 1, so you get also the negative 1, common negative 1 as a point on the graph. If you plug in 1/2, you get positive 2. And if you get closer and closer to 0, the smaller value you plug in that's close to 0, you get bigger value. So it becomes like that. It goes up and up and up. And when you plug in 2, 3, 4, then 1 over 2, 1 over 3, 1 over 4, those are decreasing values, right? So it becomes smaller and smaller and smaller like this. And therefore, you end up with this curve. And if you do the same thing, you end up with this. Okay, so if you had the time to slowly plug in more and more values, you're going to see this. And a little later, I'm going to introduce some basic functions that you have to memorize, and this is one of them. Okay. There are some graphs that you have to memorize, and this is one of the graphs. Now, along with the graph that you see, there are two more important things about this graph, which is you have this, this is not good. So it's like you have this horizontal asymptote and this this vertical asymptote. So y-axis is the vertical asymptote and x-axis is the horizontal asymptote. What's an asymptote? Asymptote is like a line that becomes indistinguishable from the graph when you draw it very far from the origin. So if you look at this, if you extended it pretty far out, and if you did this with a graphing calculator, you'll be having a hard time distinguishing the graph itself and the x-axis because they become so close together. Okay? They don't meet, but they're basically indistinguishable as you go right. Same thing here. If you go to the left, the curve becomes so close to this axis, they become indistinguishable. Same here. If you go up, far away from the origin, if you go up, 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 then this curve will be basically indistinguishable from this y-axis. So this graph has two asymptotes. One is a vertical asymptote, and the other is a horizontal asymptote. The vertical asymptote is right above the y-axis. The horizontal asymptote is right above the x-axis. All right, so that's the graph that you have to memorize. And the important thing here is, from here, you can read off the domain and range. So first of all, the x values are what you plug in, right? So that's the domain. At every point, there is some output because, see, if you recall how we came up with this graph, at 1 it's 1, at 2 it's 1/2. So at every point you think about a vertical line where it meets the graph, and the height where it meets the graph, that's the y coordinate, that's the y value, that's the output. So for any value on x, you can always draw a vertical line and see that the vertical line does cross the graph. In that case, it's an input. Whereas this vertical line here, if you draw the vertical line right above 0, it does not meet the graph, therefore that's not in the domain. Okay? Same thing on the y-axis. As I said, the height of every point on this graph is the range. It's the y value. So the y value can go up, 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 down, 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 and down, down, down. The only thing that it misses is this horizontal line. This horizontal line does not meet with the graph. Therefore, this horizontal line is not in the range. So that's how you figure out the domain and range. Did that make sense? Another way to picture this is like, think about a flashlight here. Flashlight, right? Both sides. And this is the screen, right? And you're looking at the shadow. If you look at the shadow, what point would it miss? 0 would be the only point it will miss, right? So the domain is all reals except 0. Same thing for the range. Think about a flashlight over here, flashlight over there, and look at its image, the shadow over the y-axis, and you see that over 0 there's nothing. Okay? So that's how you figure out the domain and range from the graph.